Okay, question number 4 from the 2017 free response AP. No calculator section. At time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. And the internal temperature of the potato is greater than 27 degrees Celsius for all time. So, important to know this. At t equals 0, it's 91 degrees. The internal temperature of the potato at time t minutes can be modeled by the function h. That satisfies the differential equation. So they didn't give us this. They gave us what satisfies the differential equation, dh over dt equals this thing here, where h of t is measured in degrees Celsius and h of 0 equals 91. So that was my t equals 0 is 91 degrees Celsius. Alright, so it says to write an equation for the line tangent to the graph at h at t equals 0. Use this equation to approximate the internal temperature at time t equals 3. Alright, so line tangent. I know I need this, so like I told you guys, always write this. It'll sometimes help to remind you of what you need to do. So we're writing the equation for a tangent line. So what point are we giving? Right here, 0, 91. So let's plug in 91. I know that I have x minus 0. What is f prime at this point? Oh, well, we have this differential equation. So this is my derivative. This is the derivative of h with respect to t. And at 0, 91, what is that slope at that point? So let's plug in h prime of 0 equals, we have negative 1 over 4. And when t is 0, h is 91 minus 27. And that equals negative 16. So I have my slope, negative 16. So here's the equation of my tangent line. I'm using it to approximate the internal temperature when t is 3. So really this is h and t. I wrote y and x only because I'm so familiar with that. So let's plug in. We're looking for this when we have 3. Well, 3 minus 0, I don't need to write that. And so this is the equation that we're solving for. And so we multiply these, get this over, and we get y equals 43 degrees Celsius. Well, that's h. h equals 43 degrees Celsius. Okay, so we found A. Now B. Use the second derivative to determine whether your answer in part A, this answer here, is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. Well, they're telling me to use the second derivative. There's your clue. And you know what the second derivative tells us. Think about that. We always use this second derivative to tell us if something is concave up or if something is concave down. If our function is concave up or concave down. And we have some tangent line. I just made up these pictures. Concave up, concave down. I know I have some line going through this. So if my tangent line is above this point, then I know that this is an underestimate. If this tangent line is below this point, then I know it's an overestimate. So we need to determine if it's concave up versus concave down using the second derivative. Okay, well, we know we know that this is given to us, dH over dt equals negative 1/4 of h minus 27. And now we want to take the derivative of both sides. It's with respect to t, so this will be implicitly. So d second derivative equals, well, derivative of this is just, this guy is 1. So we have negative 1/4, right, times this is just dH over dt. You could, right, if you distribute this, you have negative 1/4 h, which is negative 1/4 dH dt. Negative 1/4 times this is just a constant, which is just 0, so that doesn't count. And so my second derivative equals negative 1/4 times whatever dH over dt was, which was this whole thing. Negative 1/4 h minus 27. Negative times a negative gives me a positive times h minus 27. So now, is my second derivative positive or negative? I guess that depends on, if I multiply this in here, what is h? Well, remember, always go back to your original problem to see if you can get any clues. So let's go back to our original problem, read it through. Oh, I did circle something. Look what I circled here. We said the internal temperature of the potato is greater than 27 degrees for all time greater than 0. So that means this will always be greater than 27, and so this will be positive. And therefore I'm concave up, and therefore, since, let's write our explanation, since d2, the second derivative, is positive, meaning since it's greater than 0, and h is greater than 27 for all t greater than 0, h is concave up, therefore my answer in part A is an underestimate. Right? We said if it's concave up, it's an underestimate. That was B. On to C. Let's do C. For t is less than 10, an alternate model for the internal temperature of the potato at time t minutes is the function g that satisfies this differential equation, where g of t is measured in degrees Celsius and g of 0 equals 91. Based on this model, what is the internal temperature of the potato at time t equals 3? So they give us a model. Again, this model is a derivative, so it's a rate. And we want to know what the temperature is. Temperature is a quantity. I know whenever I am looking for a quantity, I need to integrate. Integrate. That gives me my quantity. So let's rewrite this. dg over dt equals negative g minus 27 to the 2/3. So if I'm going to integrate this, I have a dg over dt. I need to separate to integrate. And treat this as a differential. It's a differential equation. So let's separate. I'm going to do the step-by-step. G minus 27. I brought my dt over here. But remember, when I'm solving differential equations, I want the g's with the dg and anything left, or t's with the dt. So I have a negative times this. This whole thing is g, right? This is all attached to g. I'm going to divide this over to this side. So remember, if I divide this over, I can just, I'm dividing this whole thing over, I can rewrite that as g minus 27 I can negate my exponent, right? If I have a negative exponent, that means it really belongs in the denominator if it's in the numerator. And this is dg. And whenever I integrate or differentiate, I want to see those exponents so I can use my power rules. Equals, I still got a negative here, so we'll write -1 dt. Well, I got g here, I got -1 here, so I separate. And now I can go ahead and integrate. Well, I could use u substitution, but du will just equal dx. So I could just think of this as u being raised to the -2/3. Right, so this is just something being raised to the -2/3. So I add 1. I'm adding 3/3. And so I get g minus 27. -2 plus 3 is 1/3. Over 1/3. If I'm dividing by 1/3, that's the same as multiplying by 3. So I'll just put my 3 here. Equals -1. Well, that becomes -t. It's indefinite, so don't forget my plus c. So I separate, I integrate, I need to solve for c. Well, remember, go back to the problem. G of 0 equals 91. That's my initial value. So right away I'm going to plug in where t is 0, g is 91. So 391 minus 27 to the 1/3 equals, well, this is 0, so this is what c equals. And so let's calculate that. So we get 91 minus 27. Now, if this is no calculator section, so just feel free to do this. Some of you might be good, some of you may not need to do this, but take the time to do this if you cannot do this quickly in your head. Right? Let's remember how to subtract the old-fashioned way. So I got 11 minus 7 gives me 4. 8 minus 2 is 6. So I have 3, and there's 64 to the 1/3. This is the same as the cube root of 64. What times what times what gives me 64? And test it. Do you think it's 2? No. 3? It's 4. So this is 3 times 4. Therefore, C, this is 12. C equals 12. So take the time to do this so you get it right. If there's no calculator. If you can do this quickly in your head, then that's great. So I got C equals 12. I go back to the equation that I used to solve, right? This equation right here. This is the equation I used. I plugged in to solve for C. So I go back to this and I plug in for C. So I'll just write it down here. So I have 3 g minus 27 to the 1/3 equals -t plus 12. And now let's get g by itself so that we want to solve for g. So I have 3 here. Let's divide by 3. G minus 27 to the 1/3 equals -3t plus 12. Well, let me not forget. Let's this is fine, but I am looking for this. Oops, get clear. We're trying to figure this out when t equals 3. So I'm going to go ahead and plug in 3 here. So I have g minus 27 to the 1/3. So if I plug in 3, -3 times 3 is -9. Let's do this on the side. -9 plus 12, right? 9. So this is 3. So I want to get g by itself. If this is raised to the 1/3, I want it raised to the first power, so I'll multiply by 3/1. Whatever I do to the left, I do to the right. G minus 27 equals 27. Add 27 to both sides. I get G equals 54. Got my answer. So just when you see these types of questions, don't panic. You know all these different concepts. You know what the first derivative tells us, the second derivative. You know how to solve differential equations. It's just a matter of putting all these concepts that you know, putting them together to solve the problem. So just go with what you know and follow through.